Okay, so let's go over the pre-assessment for Unit 4. Before we actually answer the questions, you've probably figured out already that um, most of this Unit 4, is on exponential growth and decay, has to do with exponential functions. Now, you should have learned, we talked a little bit about exponential functions in Unit 1 way back in August and September, but you also talked a little bit about exponential growth and decay while you took either Integrated 1 or Algebra 1 a couple of years ago. So in case you forgot, this is the exponential growth formula, and you should absolutely write this down in your notes. Our exponential growth and decay formula. Growth if the value is going up, decay if the value is going down. But in case you forgot, it's a times b to the power of x. Okay, where a is our starting or initial value, and b is our growth or decay factor. Okay. B is our growth or decay factor. In other words, what we're multiplying or dividing by every time. So our B value, and I'm going to write this down here, our growth or decay factor, okay, if it's growth, okay, if we are having exponential growth, okay, B is going to be greater than 1. Your growth factor is going to be greater than 1. If it's exponential decay, in other words, if the value is decreasing, your decay factor, your B value, is going to be less than 1. So that's an important thing to realize. Okay, let's take a look at number 1 here. So for which function k does the output increase by 20% every time the input increases? So first of all, we should know that 20% is 0.20 as a decimal, just like 25% is 0.25, 10% is 0.10, 5% is 0.05, so on and so forth. So what's interesting about this is that we are increasing by a percentage. So we're increasing. We know that means we have exponential growth. We also know that means our growth factor has to be greater than 1. Okay. Now, notice none of these have an initial value. None of these choices have an initial value. Notice the question doesn't specify an initial value. What I'm going to tell you is if it doesn't specify an initial value, then you can assume that it's 1. So when I plug into my formula, a times b to the power of x, if I let a equal 1, so if I let my initial value equal 1, then it's just going to be 1 times b to the x. Okay? So the question is, what is the b value going to be? Well, the first thing we know is that b has to be greater than 1, like I said before, because it's exponential growth. It's increasing by 20%. Well, if I look at this is less than 1, so that can't be the answer. And B also can't be the answer because 0.20 is less than 1. So we're down to C or D. Now, there's a special rule, and I'm going to add this down here, and you should add this to your notes, when we're increasing or decreasing by a percentage. So if we're increasing by a percentage, okay, if we're increasing by a percentage each time, okay, my growth factor is not going to be just the decimal form of the percentage. My growth factor is going to be 1 plus that percentage. If it's a decay, if we're decreasing by a certain percentage each time, then my decay factor is going to be 1 minus that percentage. So in this case, we are increasing by 20%, which means my growth factor is going to be 1 plus 20%. So that's going to be 1 plus 0.20. 1 plus 0.20 is 1.20. So my final answer here is going to be 1 times 1.20 to the power of x. And which one is closest to that? Well, 1 times anything is itself. So the answer in this case has got to be C. Number 2, the value of a stock in 1940 is $1.25. Its value grows by 7% each year after 1940. The value, write an equation representing the value of the stock V of t in dollars t years after 1940. So I'm going to write that down here. So we're going to fill in y equals a times b to the x. So first of all, what is my initial value? My initial value of the stock is $1.25, right? So my A value is going to be $1.25. Okay. My B value, okay, first of all, 7% as a decimal is 0.07. Well, because we're increasing by a percentage, that means this is exponential growth, which means, as it says here, my B value has to be greater than 1, and my growth factor is going to be 1 plus the percentage. So in this case, 1 plus 7% is going to be 1 plus 0.07. So 1.07, in other words. So my equation here is 1.25 times 1.07 to the power of x. And what's significant about this equation is now I can plug in any value for x. I can make that exponent any value to figure out what the value is, a certain number of years later. So if I wanted to find the value of the stock 10 years later, I would make it 1.25 times 1.07 to the power of 10. If I wanted to find the value 20 years later, I would make x be equal to 20, so on and so forth. Okay, so for B, what does V of 50 represent? Well, V of 50, remember, whenever we use function notation, the value that's in the parentheses is what we plug in for x. So V of 50 means plug in 50 for x. Okay? Now, the question says, what does it mean in this situation? In other words, what does that mean in the context of the problem? Okay, yes, it means plug in 50 for x here, but what is that value? If I plug in 50 for x, what is that value going to tell me? It's going to tell me the value of the stock 50 years later. If I plug in 50 for x, that's going to tell me the value of the stock 50 years later. Value of the stock 50 years later. Okay, that's what V of 50 represents in this situation. Okay, so that's number 1 and 2. Let's go ahead and look at number 3. Go to number 3. Having some technical difficulties here. All right. Number 3. The table shows the area A of n in square centimeters of a piece of paper after it is folded in half n times. So this table right here shows the data. Now, before we actually answer the questions, it's important that we realize what this table is saying. So what this table is saying is if I fold it in half, if I take the piece of paper and I fold it in half once, it has an area of 140. If I fold it in half twice, it has an area of 70. If I fold it in half 3 times, it has an area of 35, so on and so forth. So for part A, what is the area of the sheet of paper? So in other words, what is the area of the paper before we've started folding? So if I were to add a row and let n equal 0, what is the area of the paper with 0 folds? Well, we're just going to follow the pattern here, okay? The pattern is as we move down, we have, right? 140 divided by 2 is 70, divided by 2 is 35, so on and so forth. So to keep that pattern true, that would mean the original piece of paper has to have an area of 280. So what is the area of the sheet of paper? 280. Write an equation representing or expressing the area A as a function of the number of folds n. Okay, so again, what's our initial value? We just found our initial value of 280. And what did I say the pattern is as I move down the table? The pattern is the area is halving as we move down. So my decay factor is going to be a half. So you could write that as a decimal, like I am. You could also write it as a fraction, a half. It doesn't matter to me. At the end of the day, the equation is 280 times a half to the power of x. So if I wanted to find the area after 7 or 8 folds, I would make the exponent here 7 or 8. Okay. Number 4. By what factor do the values of f grow when the input increases by 1? So f is the bottom graph here. So when x increases by 1 from 0 to 1, okay, the output goes from 50 to 150. Okay, 50 to 150. If I do the math, I believe that's tripling, right? 50 times 3 is 150. So the growth factor is going to be 3. Now, let's say you couldn't figure that out. Let's say you couldn't figure out that going from 50 to 150 was multiplying by 3. You can figure out the growth factor by taking any value on the graph and multiplying it, dividing it by the previous value. So if I take a value of 150 and I divide it by the previous value of 50, do I get 3? It's 150 divided by 50 equal to 3, and the answer is, of course, yes. So the growth factor for that one, for that first graph, is 3. Okay. How about B? So for graph G, the top graph here, by what factor do the values of G grow when the input increases by 1? This one's not quite as obvious. We go from 100 to 250. So that one is not quite as obvious. You could figure out 100 times what is equal to 250. But if you can't, again, just take the value of 250, divide it by the previous value. So put that in a calculator. 250 divided by 100, you should get 2.5. So that means my growth factor is 2.5. 100 times 2.5 is equal to 250. And that is it for number 4. Number 5. Not sure what's going on here.